This slide set is about IPv6 addresses. IPv6 addresses have 128 bits, which are by default represented as 8 blocks separated by colons. Each block contains 4 hexadecimal values so that it represents 16 bits. As you see in the example, an IPv6 address is quite long. To make it easier for humans, rules have been defined to shorten the representation. At first, leading zeros can be omitted in every block. Furthermore, blocks which are completely zero can be skipped, and it is also possible to summarize several skipped blocks. Such a summarization is only allowed once, because there would be ambiguities otherwise. For mixed environments where we find both IPv4 only and IPv6 only networks, special representations have been defined. In these addresses, the last 32 bits of the IPv6 address are written in the decimal manner separated by dots, which is usual for IPv4 addresses. The last 64 bits of an IPv6 address are used as interface ID, that is, to distinguish between different interfaces within a network. The first 64 bits are used to specify the network part. Within these bits, n bits belong to the global routing prefix, and the remaining bits are used to identify the subnet. There is an example on the slide. RIPE NCC has received a /23 address space. It uses this address space to form address spaces for ISPs. In the example, you see the /32 address space that is assigned to the German research network. Therefore, from the perspective of DFN, the n is 32. DFN provides this address space to universities in Germany so that an example university has a /48 network. This university can use 16 bits to define its own networks. In addition, an example network from within this university is given, where n is 64. Similar to IPv4, there are some IPv6 addresses with a special meaning. The address where all bits are zeros is the unspecified address, which can be used temporarily to be replaced by a valid address. The address with 127 zeros and a 1 at the end is a loopback address, and it has the same meaning as the localhost address 127.0.0.1 in IPv4. An important difference of IPv6 in comparison with IPv4 is that each interface can have several IPv6 addresses. In IPv4, each interface has just one IPv4 address. IPv6 defines different scopes. These are areas where the IPv6 addresses are valid. In the link local scope, the IPv6 address is only valid in a local network and is limited by routers. There is a certain prefix which is reused for all link local scope addresses. The site local scope is similar to private IPv4 addresses. That is, these addresses are valid for routing inside the location of an organization, but they cannot be used in the internet. An organization can choose a 40-bit site ID by random and combine it with the start bits FD. In case of a merger of two organizations, this is only a problem if the site IDs are identical and they also want to merge their networks. For the address space FC, a global assignment is planned so that this problem would not occur. In addition to these address spaces with limited scope, there are also globally valid IPv6 addresses. Anycast addresses do not have a special syntax, so you cannot identify just by knowing an IPv6 address whether it is an Anycast address. Anycast addresses can only be used as destination addresses, not as source address. They can be assigned to router interfaces, but not to host interfaces. There is a specific address space for multicast addresses. Multicast addresses are also defined for different scopes, which is indicated in 4 bits of the multicast address.